Hello everyone and welcome back to another video. Today will be the first video which is going over the user interface side of things. So in the previous video we went over the foundation functions, and in this video we'll go over the UI and all of the different functions which are involved within that. So let's have a quick look at the actual code. Okay, so if you want to follow along on GitHub, the UI functions are basically over here inside the code, located from lines 159 to 188. So now let's go over each of these in turn. So we basically have this draw grid. So what this does is this actually displays the grid to the user. Since if we just have a quick example as to what exactly the grid is. Okay, so as you can see on the screen, this is basically the board which we have. It's made up of several different components though. It has the 8x8 square, which has all of the different pieces, all of the different pieces, as well as all the different colors as well. And now, not only does it have the colors of the pieces, but it also has the colors of the squares. And now, not only are the squares not only do they have different colors, but they're also alternating. So we need to break all of this apart into several different functions. So the first of which is we have a function which determines each of these squares. It basically outputs all of the squares. And then the other function outputs all of the pieces. And then we have a third function which puts both of them together and then outputs the pieces on top of the squares. Okay, so now let's have a quick look back at the code. We have the draw grid. This is the one which puts both of the other functions together, the draw squares and the draw pieces. So if we look at the draw squares, what this does is we have the two different colors. So this is basically the light color which we have, and this is the dark color which we have. You can customize these to being anything you want, but in this case I've chosen Bollywood and Chocolate 4, since both of them create a really nice look and feel to the actual code. So but for actually drawing the squares, what we do is we iterate row by row, column by column, and then we determine which color. We'll go over exactly how this bit of code works, but we have a function which determines which color a square should be colored. And then what we do is we actually draw that. So for this we use Pygame. So I'll quickly go over what Pygame is. Pygame is basically a Python library which is responsible for all of this user interface side of things. It's really, really useful. In this one we don't use it that much. It's still very useful in this program, but it's way more useful in the things where we have several different moving parts, like animations, and it's an incredibly useful library. But for our particular chess engine, we're mainly concerned with it displaying the actual board. So the way we call the py.draw function, and then within that we draw a rectangle basically, since all of these squares are ultimately rectangles. And then what we do is, again, we have to specify the screen. The screen is basically just the overlay which we will be drawing the squares onto, as well as the color. And then we specify exactly what shape we're drawing. So we're drawing a rectangle, and then the dimensions of the square are basically c times square size, and then r times square size, where c and rho are the columns. This is basically the vertical and horizontal offsets, which we will start by which we'll basically identify by c and r multiplied by the square size, and then the actual dimensions of the width and height of the actual rectangle featured by square size. So now if we go up to where square size is defined, so square size is basically just the width and the height, which each have 512 pixels, divided by 8, since there are 8 squares made up of the entire chessboard. Okay, so that's basically how we draw the squares. And then now I missed out this function when we went over the function the first time, but now let me quickly explain how exactly this works. So if we go back to the square, sorry, the board, you'll notice that the top left square, this particular square, it's represented by coordinate 0, 0. This is represented by 0, 1, etc. So 0, 0, this basically, how we determine which color a square is if it's on an even row, then it basically, if it's on an even row and even column, then it has to be a light color. If it's on an odd column an odd row over here, it has to be a light color as well, okay? So if it's even row and even column, then it will be represented by a light color. Odd row, odd column, it will also be represented by a light color. So that basically means that if we consider modular arithmetic here, then we basically know that on an even row and even column, both of their remainders when divided by 2 is 0. So it would be 0 divided by 0 plus 0, which is just 0. So it will basically be the first element inside the array. And if it's an odd row and odd column, then it will be 1 plus 1 in mod 2, which is 2, which is equivalent to 0 in mod 2. So either way, both of them will access the first array element within the colors, which in this case is the light color. And now if we go back to the board, then we can basically see for the dark color, we have two different ways in which we can get the dark color. Either it's on an even row and an odd column, or it's on an odd row and an even column, okay? So it's either on an odd row, even column, or even row, odd column. And then that basically means the remainders mod 2 are going to be 1 plus 0 or 0 plus 1. And either way that corresponds to a total of 1. So 1 mod 2 will basically be the second element inside our array. Okay, so that'll be how we access the dark color. And now it's also worth mentioning you can change these colors to whatever you want. You can have like white and black, for example. I've chosen these since they look the most sophisticated, but it's completely up to you. And now we also have those draw pieces. So what this draw pieces is it basically takes all the different pieces and it basically goes over the representation of all of them. So each of the pieces I've represented with a unique like image basically, since for example like a white pawn would be represented by this particular shape, a white knight would be represented with this one, and then we would have a unique piece image for each of the pieces as well as each of the colors. So each piece on the board basically has a unique like representation using the images. Okay, so and the way I've represented these is through using an array of images. So if we go to this initialization function, and then we go down here to the images, we have a dictionary, and what this does is it basically has each of the pieces, its numerical value, and then as well as its file location. So if you want to know the file location, there's a link in the description. That will basically provide you the download to all of the images which I'm using. So it's basically providing the file path. So images plus string of piece plus .png. So string of piece would basically be string of 1, for example, would represent a black pawn. .png, that would give you the black pawn image. And then once again, we provide the square size, the dimension of the square size. Okay, and then we basically, this particular bit of code just iterates through each and every piece which we can possibly get, and then all of that would make up the images dictionary. So for each of the pieces, if the piece is not 0, then it will basically be a piece, and then we display that particular piece on the board. So the way we do this is we do the screen.blit. So screen is basically the overlay which we have, and .blit is a function within Pygame, which basically just displays the function on top of something else. So and then once again we provide a rectangle as well as all the dimensions. Okay, so all three of these functions, between all three of them, they display the actual images. But we also have one more like use case. Let's say we basically reach a position once it's checkmate. So we want to display something on the board which represents that it's actually the game is over. So the way we're going to do this is if we go back to the program, excuse me, we'll basically be drawing the endgame text. So what this does is it basically takes the font, line, as well as the location of the line, and then it basically displays that particular message on the location which is provided. So and we've done this in any, we can do this in any font, which I've chosen green here just to make it stand out compared to all the other white, black, like all the other darker shades on the board. And this basically just displays the final image and final message, sorry, and telling us that the game is basically over. So between these four functions, that's basically the end of the UI side of the code. So I really hope you enjoyed watching this video. Hopefully you learned something new about how UI works, maybe how Pygame works internally. And I really hope to see you in another video next time. Thanks very much for watching. Bye.